This video will continue our discussion of vector fields by taking a look at vector fields in 3 space. So we're going to do a matching. You can see all 4 on your notes, but there they are. So let's begin. Okay, so the first function, just x, y, and z, that means as I get close to the origin, the vectors are going to get small, and as I go away from the origin, they get bigger, and the vectors are just x, y, and z, so that means as I go further out, they're going to point away from the origin. If I look at all 4 pictures, there's only one option of it going out away from the origin and getting bigger as we go out, and that is, we should label these. A, B, C, D. I meant to do that. Okay, so this is going to be A for sure. They are going out away from it. Okay, the second option there, we have 0, 1, 0. Well, that means it's only going in one direction. And the only vector field here that has only one direction would be D. Right, it's all going to the right. That's assuming that's the y direction, the y component. The way we typically write it, that also falls into that, right? X is sticking out at us like this, y is going out like that, right? And then we have some kind of z. It's right there in the middle. It's kind of harder to see in these. All right, let's take a look at 2. Notice that we're missing a k component, so that means everything's going to be 0. So I'm going to deal with this just each like flat plane. We'll call this x and y because that will be the same as the rest. But let's think about, we're going to use that same technique that we used earlier, thinking about what the sign of everything's going to be. Okay, well the x component is a y, so it's positive. The j component is an x, so it's positive, but that negative out front is going to make it a negative. The denominators are they're all positive, so it won't matter. So this is going to be a negative here. It's going to be a negative x because y is negative. Remember, that's y here. And then it's going to be another negative. Actually, it'd be positive. Both of these are going to... No, that'll be negative. They're both negative. Okay, forgive me. Positive. X is positive over here. So that means component's going to be positive in this thing. That negative makes it negative. Cool. All right, this quadrant. The y is positive, so the x component's going to be positive. X is negative, and that negative is going to make that a positive. Here, the y is negative, so the x is going to be negative, or the I component's negative. The second component is an x. It's going to be negative, but it's going to make it a positive. You can kind of see the symmetry in the picture. Okay, so this is just a flat plane. It's not three-dimensional. I know this goes like that, down to the left, left and up, right and up. All right, so it's actually rotational. And this picture I think is misleading because we do have a 0k, and I remember when I pulled this, and I always steal these, I didn't make them. This looks like it's going up to me, and it's kind of misleading, but it's the only thing that makes sense here. This isn't circular over here on the left, right? So I think those may just be the way that the inside circles kind of manifested, the way they look. They're supposed to be flat, but in this two-dimensional projection, they don't look like it. So this tells me it's circular at each plane, and then we could change the z to whatever we want. We could have had f, x, y, z, really. And z in this case would spit out a 0k every single time, giving me a bunch of these flat circles. All right, so that means this answer is B, leaving this to be C, but let's make sure we make sense out of it. The negatives, if the negatives weren't there, notice this negative, that negative, and that negative. If those weren't there and they were positive, they'd all be spitting out like A, right? But since they're negative, they're all going to be going in. And then this is a terrible, I stared at it for a while, and I'm like, okay, well, what does this do? The bottom. Well, the bottom, all I know is it's going to, if I plug in big or small x, y's, and z's, I'm going to get a number out that's going to be even smaller because it's, or it'll be bigger because it's 3/2 power. So we'll get a little bit and then some. But the point is, actually, it'll be smaller if x, y, and z end up being fractions. So the point is that this number on the bottom, oops, still my highlighter, this in the bottom is going to get very small as we get close to the origin. As we get to the very origin, it's going to blow up, right? This is going to get small, and then we're going to divide by a very small number. So it's going to blow up, and you can see that in the vector field here. They didn't do a great job of showing it, but as we get closer, the vectors get longer. It's kind of hard to see, and it's kind of hidden in there, but it is there. Again, the matching can be pretty difficult at times. I try to look for some kind of pattern, and I start memorizing things. I know this projects out, meaning if I made them all negative, they project in, stuff like that. This thing being a unit making it a unit vector also helps out in a way, because and then we can look at if we look at B, they look like they're all the same size. They should be. Actually, this looks smaller out here. And maybe that negative that's dealing with it. It just may be the projection onto a 2D plane like we're doing here. The picture is projecting onto it. All right. Again, there is a grapher for these. The next two examples, I'm going to show you guys just how to plug them in again, and make sure that you're great with using a 3D plotter.